Another good application of differentiation techniques is the topic about optimization. Okay, so when we talk about optimization, basically we are parang minimizing or maximizing our variables. So, kung sa related rates, mga how fast is this variable changing with respect to this variable, ganun ang mga tanong. Ito naman, meron tayong maximum and minimum na mga terms dito. So, what will we do to get the minimum value, to minimize that variable, or to maximize that variable? Yun yung parang keywords mo when checking kung anong type of problem to, related rates ba or optimization problem ba. Nevertheless, pareho lang naman halos ang approach nila. Kasi you talk about equations of different variables, relationship ng iba't ibang variables. So, beginning with our first example muna siguro, ayan. Teka lang, what are the rules pala that you need to parang understand when talking about optimization? Okay? First thing na kailangan alam mo pag optimization ang pinag-uusapan is, una, you can establish your variables. Okay? Okay ko dito ha. Establish the relationship between variables. Or the relationship siguro to be optimized. Establish the relationship to be optimized. So basically, ano yung mga variables mo, no? Kasi yun yung i-optimize mo eh. So when you talk about optimize again, i-minimize mo siya or i-maximize mo siya. To be optimized. Okay? Then, number 2 na gagawin mo is parang to have all the variables expressed in just a single variable. So, yun ang gulo nun, express the equation in one variable para mas mabilis. Okay? And how are you going to express this one? Paano mo siya i-express in one variable? So, you need to get the relationship. So, that could mean maghahanap ka pa ng isang equation na marirelate mo yung dalawang variables na yon other than the equation to be optimized. So, basically, parang, kumbaga, dalawa yung equation mo or more. No? The first equation would generally be the equation to be optimized. And the other equations na pwede mong makita, no, ma-establish, would help you parang get the relationship so as you can express the equation to be optimized in only one variable lang. Okay? So, mamaya sa example, you will see naman what I'm really talking about here. Ayan na. And then, finally, you need to apply differentiation techniques. Okay? Differentiate to compute for unknowns. Okay. Yan yung tatlo na kailangan mong tandaan for optimization problems. So, let's try to compute our first problem here. Nakapag-prepare ako ng siguro 6. Most of these are the common things na na-encounter ko personally when taking my board exams as a civil engineer. Okay? Burahin ko muna. And so, number 1 is a rectangular lot 625 square meters in area is to be fenced on all 4 sides. Okay? A rectangular lot, 625 square meters in area, to be fenced on all 4 sides. Its dimensions require the least amount of fencing. If the fence costs 50 pesos per linear meter, what is the total cost of Parang having this land na fenced siya. Okay, so a lot is going on dito. Sa isayin natin ha. Meron tayong rectangular lot. Familiar kayo lot sa rectangle na? We have a length and a width here. Alright? And then, it is said that the area, so ibig sabihin area nito is fixed. Binigay 625 square meter. Okay? It is to be fenced on all four sides. Ayan, pag ganito. Take note, sabi niya, its dimensions requires the least amount of fencing. Okay? I have to put emphasis here. Pag sinabi niya kasing least amount of fencing, that talks about minimum. Diba? When you say the least amount of fencing, dapat pinakamaliit na amount of material ang magagamit niya dito. Pinaka-konti. Yung siguro tamang pa. Pinaka-konti. Yan. Okay. And the cost of fencing daw is, lagay ko dito ha, cost is 50 pesos per linear meter. Per linear meter. Oh. Pag sinabi niyang linear meter, ano lang yun, parang isang metro lang talaga yun, hindi siya square meter, linear meter siya. So it talks about the perimeter, parang somehow perimeter yung i-fence niya dito, which is correct, di ba? Kasi on all four sides nga daw niya i-fence. Now, ang question ko muna is, do we know the sides of this rectangle? No? We don't actually know it kasi nga, sabi niya, the least dimension daw ang hinahanap natin. So as, the dimension daw ang hinahanap natin for the least amount of fencing. So I'll set this one na lang as my x and this one is my y. Yan yung hindi natin alam. Yan yung hahanapin natin. Alright? Yan yung hahanapin natin muna. Diba una kong sinabi kanina, the first thing that you need to do for optimization problem is to identify your equation to be optimized. So meron tayong area dyan, meron tayong cost na pinag-uusapan, pero ang gusto niyang i-minimize dito is the amount of fencing. So that should be your working equation. And when you talk about that, it pertains to the perimeter of the fence. I hope nag-a-agree tayo lahat na perimeter yung i-optimize mo, not the area and not the cost. Okay? Balikan ko ng problem ha, to give a little more emphasis pa talaga. Okay? Sabi niya kasi, cost yung hinahanap natin. What's the total cost? But, what is to be minimized again is the amount of fencing. Dito lang ha. Kasi may mga times na cost yung hinahanap din, cost din yung minimize. In this case, perimeter tayo. Okay, masyado akong makulit, pero i-speed up mo na lang kung nakakulitan ka. Okay, ayan. So, perimeter ng rectangle is 2 times the quantity x plus y. Then, second step na kailangan natin gawin, tinuro ko sa inyo is, we need to have this formula here na in terms of one variable only. Okay? How are we going to do that? By checking your given. Ano yung ibang relationship that could parang relate x and y together? Okay? May binigay siyang area dito. And we know that area of a rectangle is x times y with respect to our dimensions here. And sabi niya, ang area is fixed at 625. So x times y is equal to 625. Or basically, I can have x as 625 over y. Tama yun, di ba? Di-divide mo siya dyan? Okay. So, ito yung isang relationship that is step 2. And putting that here now, para ma-express natin siya into a single variable, this would be 2. X natin from this one is 625 over y. Plus, meron tayong y dito. Alright? So, simplify natin a little further. This would be 1 to 50 over y plus 2y. So, this time, na-express mo na siya into a single variable. Then, buta tayo doon sa third natin na step, which is differentiation. So, pwede mo siyang i-differentiate directly now. So, this one is, ang differentiation natin is itong variable na to over yung isang variable na natira. That should be dp over dy. Okay? So, this would be, differentiating this would be negative. Sulat ko siya in this manner, ha? Ako kasi hindi na ako masyado nag-deal with parang division kung hindi ko naman talaga kailangan. So, pwede mo siyang isulat as 1 to 50 raised to negative y raised to negative 1. Naiakyat mo siya dito para mas madali siyang i-differentiate. But, if you can do it using the division na derivative, pwede naman. Okay? So, ganyan ako mag-differentiate. Now, putting that here would be negative 1 to 50 y squared, right? Y raised to negative 2, I'm sorry. 1 to 50 times y raised to negative 2. Cross ng derivative. Plus, ito sa kabila would be 2 na lang. Okay? Yan. So, cut off sandali dito. Continue natin ang ating solution on this other side here. So, this would be dp over dy. I-rewrite ko siya, ha? 1 to 50 ito over y squared this time. Positive na si y squared kasi binalik ko siya sa baba, plus 2. Okay? So, pag nag-optimize ka daw, if you are to get the minimum and maximum, yung variable na dinidifferentiate mo or in-optimize mo, that in this case, yung perimeter yun, after differentiating, isi-set mo daw siya to 0. Alright? So, setting that to 0 now, ta-transfer ko yung negative 2, positive 2 on the other side. That would be negative 1 to 50 over y squared is equal to negative 2. Tinranspose ko lang siya. And cross-multiplying this and removing the negative sign, 1 to 50 over 2y squared. Divide mo si 1 to 50 by 2 and take the square root of that. Bibigyan niya tayo ng y value which is equal to 25 meters. Okay, 25 meters y. Consequently, yung x natin which is equal to 625 over y, or the 625 divided by 25 din na y, that would also give you 25 meters din. So, dimension natin would be 25 by 25. Square siya actually, no? So, tama pa rin yung problem kasi a square is still part of the rectangle family naman. Ayan. Ito yung dimension. But take note, ang hinahanap niya kasi dito is ano yung cost, hindi yung dimension. So, ano yung cost given this dimension na? 50 pesos siya per linear meter. Ayan. So, if you're still trying to absorb this one, pause nyo yung video. Sa mga okay na, i-erase ko to para makompute natin ang ating final answer. Alright. Cost natin, paano i-compute yan? Ko-compute mo yung ilang linear meter siya, no? So, ang cost natin is ang perimeter times 50 per meter, per linear meter. Alright. So, ilang linear meter ba ito lahat? Kunin natin si perimeter niya. Perimeter is 2 times x plus y. Tama? That's 25 plus 25. Tapos yung cost, multiply ko ulit dito by 50 per linear meter. 25 plus 25 is 50 times 2, that is 100. 50 times 2 is 100 linear meter siya. This one is 50 pesos. Lagyan ko ng unit dito, ha? 50 pesos per linear meter. Cancel natin yung linear meter. Ngayon, meron tayong cost ng ating fencing. Our total cost now would be 5,000 pesos. And this is our final answer. Right? Okay, moving to our next problem. A metal box without a top is to be constructed from a square sheet of metal. It is 20 cm on a side by cutting square pieces of the same size in the corners of the sheet and then folding up the sides. Find the dimensions of the box with the largest volume that can be constructed in this manner. Okay, yun yung tinatanong niya. Sige, don't forget ang pinapakompute dito, find the dimensions of the box. Alright? So, as the volume is, baka na, so as the volume is maximum, the largest volume. Okay? So, since volume yung minamaximize dito, yan, try muna natin siguro i-drawing yung figure na sinasabi niya, no? Kasi very common itong problem na to. Ayan, meron daw tayong isang sheet of metal na 20 cm ang kanyang side. We have, this should be a square drawing. Ayan. 20 cm on one side, on all sides siya. Kasi we have here a square sheet of metal. And then you are to cut a little square on each corner of it. So I hope you are parang figuring out ano yung magiging itsura nito. So you are to cut that one and then if you fold up mo daw siya for you to create a 3D box. Na 3-dimensional figure ang gagawin natin dito. And that box would look like this one. Ayan. Then, ito natin. Okay. Ganito yung magiging itsura ng box. So, ang question ngayon is, ano doon yung magiging dimension ng box na to para maximum ang volume? Ayan. Since we don't know ano tong ikakat natin na portion, we set that one as X. And this side here is also X because this is a square cutting here. And if you can imagine, you flip it up. Okay? And this would be what it would look like. So what happens here now is, this side here would be how much? This would be 20 minus that's a little loud. So, I'm sorry for that noise with Thomas. I can't avoid that. I'm actually in a very loud neighborhood. So, I hope you won't mind. Okay, so if this is X here and this is X here, this would be how much? 20 minus 2X. Right? And so is the side. So is the side. This would be 20 minus 2X. So putting that here now, is it right to say that this side here is 20 minus 2X and this side here is 20 minus 2X as well? Tama, di ba? Kasi yan yung iaangat mong paganyan and that will serve as the length and width of your box. And the height of your box is X. Sana clear sa inyo yung ganyan. Alright? So, given that drawing now and given that analysis now, let's proceed to our step 1. Step 1 is to establish your equation to be optimized. So that is volume. Volume daw ang gusto niyang largest. I'll put it here. What would be the dimension for largest volume? So, volume of a rectangular prism is length times width times height. Ma'am, sinabi niya dun sa problem na this is a metal box without a top. Does it matter for this computation? So actually, it wouldn't matter if without a top siya. It would only matter if we are talking about surface area. But since for this problem, we are optimizing the volume, we are getting the largest volume out of the dimensions, or we're getting the dimensions to give the largest volume. So it has nothing to do with that statement na without a top. Okay? But again, for surface area computations, it matters a lot kung sinabi niyang without a top or with a top. A closed box or an open box. Yan. So now, having said that, let's proceed. Now, lagay ko yung length, width, and height ko. Length natin is 20 minus 2x, and so is the width. So, I can write that as 20 minus 2x squared. That's length times the width. And your height here is x. Okay? Next step natin is to express our optimization equation in one variable. But since one variable na to, we only have x here, we can proceed directly. Okay, pwede na agad tayo puntahan na natin yung ating computation, which is step 3, the differentiation part. So, you have a choice to apply your multiplication principle sa pag-compute nito para yung UDV plus VDU, pwedeng ganon. Ako naman, what I usually do is, ina-algebraic expansion ko na lang siya muna. So, depende yun sa inyo, no? Pareho lang naman yung magiging sagot niya. But maybe for this case, to practice our UDV plus VDU, let's try using that one. So, U natin in this case is 20 minus 2x squared. Okay? That's again a little loud. I'm sorry guys. No, everyone's awake now. I tried waking up at dawn to record alarm. Everyone's awake. So that's 20 minus 2x squared. U, that's U. Your dv is the different derivative of this, which is 1, plus this 1. This is your v, and then we get our du. Du natin is applying the chain rule. So, dapat mag-chain rule ka dyan. You have 2, you have 20 minus 2x, and the derivative of what is inside this quantity, and that's negative 2. This should be, by the way, dv over dx na, no? I'm sorry. dv over dx. Kasi nagdi-differentiate ka na dito. Okay? So, we need to simplify it now. dv over dx natin is how much? So, 20 squared, 20 minus 2x squared. Expand ko yan ngayon. That would be 400 minus 20 times 2 is 40. This would be 80x plus 4x. Ayan. Okay. So, ito madalas maraming nagkakamali kasi ang nangyayari 400 minus 4x squared lang ang ginagawa nila. But this should be 400 minus 80x plus 4x squared. On this side naman, we have negative 2 times x, that is negative 4x times 20 minus 2x. Simplifying it a little further pa. We have 400 minus 80x plus 4x squared. Distributing this one is negative 80x plus 8x squared. Okay. So we have dv over dt. Unahin ko yung x squared na part. That will give us ilan to? 12. Right? 12x squared. This and this. And then we have 160. Negative 160 x plus 400. Okay. Ayan. And that should be equal to 0. Right? Optimization equation natin should be equal to 0. Okay. And the dog is so loud. Okay. So since wala tayong space to finish up this problem, I need to erase something here. And so you just go back to this part of the video if you aren't done observing this one. But I hope itong figure na to is now clear. So I'll erase it muna. And this one here. Okay. So, ayan. Maybe we should simplify this muna, no? Let me try to check. So, I guess we can divide everything here by 4, right? So, let me do that before we move on to this side. Let's divide everything here by 4. So, that means this side and on the other side of the equation, divide natin. So, this would now be 3x squared. 3 na lang siya, minus 40 x plus 400. I know, plus 100. Sorry. Equal to 0. Okay. So, assuming that you don't have your calculator to compute for the roots of this one, you need to go back to how we used to compute it using our how do you call this equation? Your quadratic equation. So that's negative b plus minus square root of b squared minus 4ac over 2a. That's x. B is this one, negative b, that should be 40, positive na this time, plus minus b squared is negative 40 squared. That is 40 times 40, right? That would give us 1,600 minus 4, 3, and then c is 100. So let me finish this problem before I move into my next recording location because the dogs are alive now. I hope you still don't mind. Let me finish this one. Okay, so that's it. This is, how much is this now? 40 plus minus square root of 1,600. So this would be 12 times 100 is 1,200, right? Divided by 6. Okay, and this is 40 plus minus the square root of 1,600 minus 1,200 is 400 divided by 6. And that would give us how much? 40 plus minus square root of 400 is 20 over 6. So let's have it here. X1 is 40 plus 20. That is actually 60 divided by 6 is 10. And gives you your X1. And X2 is 40 minus 20. Okay, that's 40 minus 20 is 20 over 6, right? 20 over 6, or that's 10 over 3. Okay, so these are our X values. And what should be our final X value here? Okay, our final X value is, should it be 10 or should it be 10 over 3? Okay, you can actually check that. No, but the more logical value of this X here. Okay? Kasi if i-recall nyo kasi yung drawing kanina, no? Ganito siya, di ba? Para alam mo yung pipiliin mong sagot dyan kasi parehong positive yung sagot eh. Pero isa lang dyan ang pinaka-logical na sagot. O, ito yung magiging X mo, ito yung magiging X mo. And remember, 20 itong total na to. Okay? If gagamitin mo tong 10 as the value of X, 2X na kagad yan dyan. 2x is equal to 20. So, parang naging ganito yung cut mo. Diba? Eh, wala ka nang mabubuong box niyan. So, the more logical answer should be itong x2 na 10/3. That is your height. And if that is your height, we can compute our length and width. Lagay ko na lang dito. Length and width natin is equal to 20 minus 2x. 20 minus 2x. Length and width is 20 minus 2 times 10/3. That would give you how much? 20 minus 20/3. Okay? So, let's see. Okay, our final answer now is 40/3. Tama? 40/3. Okay? So, to give you the entire answer, I'll just write it here na lang. Our complete answer is, we have a box that is 40/3 by 40/3 by 10/3. And this is in the unit. We have a unit given from our problem. We have cm. Okay, that's our final answer. Alright, we have another problem here. A rectangular field adjacent to a river is to be enclosed. Fencing along the river cost $5 per meter, and fencing for the other side costs $3 per meter. Okay. The area of the field is to be 1,200 square meters. Find the dimension of the field that is the least expensive to enclose. Find the dimension of the field that is the least expensive to enclose. So what is our variable to be optimized here? Least expensive to be enclosed, that is your cost. So your cost is to be optimized here. Ano ba yung itsura ng ating figure? So we have here a rectangular garden that is to be fenced, and one side of it is adjacent to the river. So say this is the river here, and there is also a fencing on this side here. Okay? This side to be fenced along the river daw is cost $3 per meter. $3 per meter, whereas the other sides would be, wrong. This is $5 per meter. Okay, that's $5. And this other sides here cost $3 per meter. Alright. And the area is given, right? The area is 1,200 square meters. That is a fixed area. Alright. So what is the dimension of the field to require you the least cost? Okay? So since we don't know yet the dimensions of the field, kasi yun yung tinatanong sa atin, no? So we set this one as our xy again. So let's have this as our x and this one our y. This side here as y. So if this is x and y, and if we are to set up our cost equation, kasi yun yung tinatanong, no? Yun yung gusto i-optimize the cost. So setting up our cost equation, that would be every x dito, that would cost you $3 per meter. So that is 3x on this side. On this side, this is $3 as well. So that should be 3y. Okay. On this side is another x dimension here at $3. That's another 3x. And finally, on this side here, this is a y dimension here. And that should be 5y. That is your cost equation. And if we are to simplify our cost equation, that would bring us to 6x. And we have 8y here. Okay, that is your step 1 to identify your equation to be optimized. Step 2 is to express them in one variable. And for you to be able to express them in one variable, gamitin mo ang given na binigay sa'yo, which is in this case, area. The area of this garden to be enclosed is 1,200. And the area is equal to x times y. 1,200. So that means your x now is 1,200 divided by your y. So, having this here, lagay natin siya ngayon sa loob ng ating cost equation. This would be 6 times x natin is 1,200 over y plus 8y. Simplify ko siya muna before we differentiate it. 1,200 times 6 is 7,200. 7,200 over y yan, di ba? 7,200 over y. O, akit ko na lang yung y. Y raised to negative 1. Plus 8y. Ayan na. So, naka-step 1 na tayo. Naka-step 2 na din. And finally, our step 3 is to differentiate this one. So, differentiating this will give us, patuloy ko on this side ha. Okay. This would be dc over dy. We are differentiating it against y. Is equal to negative 1 times 7,200. Y raised to negative 2 plus 8. And that should be equal to 0. Right? Okay, let's simplify it further. Gawin ko ngayon, negative 7,200 over y squared na siya. Diba? Equal to negative 8. I hope you are still following, guys. So, ito siya is sinimplify ko lang, no? Nilagay ko yung y ulit sa baba and then tinranspose ko na kagad yung 8 dun sa other side. That's why negative 8 na siya dito. And then cross-multiplying this one and removing the negative sign, this would be 7,200 is equal to 8y squared. Divide natin by 8. That would give us 900 equal to y squared. So that y is the square root of 900 na 30 meters. So ito din gagamitin mong y. And therefore, x is, ito si x, di ba? 1,200 over y mo na 30. That's 40 meters. So what we are looking for as the dimension here ay we have 40 by 30. 40 meters by 30 meters. Para ang cost mo daw is minimum. Okay. A crypto expert is deciphering a computer code. To do this, the expert needs to minimize the product of a positive rational number and a negative rational number. Given that the positive is exactly 8 greater than the negative, what final product is the expert looking for? Okay, so we have a problem here na the problem would like us to have two numbers. One is negative and one is positive. Okay? And the positive number is 8 more than the negative number. So since we don't know what the negative number is, we can set it as x. And if the positive number is exactly 8 greater than the negative number, so it should be x plus 8, right? I hope you are agreeing with that. And what the problem would like to do is to maximize, right, or to minimize the product of these two numbers. So our equation to be optimized is the product. So since we are looking for the product, the equation should be x times x plus 8, right? Okay. For step 2, express it in a single variable na express na yun sa problem. So what we can do now is, ano na lang siya na, expand. This would be x squared plus 8x. Then we move to step 3 na ngayon. We need to optimize this one. So this would be, differentiating it would be dp over dx is equal to 2x plus 8. And this value should be equal to 0. So this is now 2x is equal to negative 8. Pata-transfer ko siya sa kabila. And x natin dito would be equal to negative 4. Which is correct based on our assumptions. Kasi ang x natin is a negative number. So kapag positive yung lumabas dito, baka nagkamali ka lang sa mga ang pag-designate mo ng variables mo dyan. But since this is a negative number, ito na mismo yung hinahanap natin na value for x. And consequently, our positive number, which is x plus 8, would be equal to negative 4 plus 8. That is positive 4 naman. Okay? This one is our x plus 8. Positive 4. So these are the two numbers that the encoder are actually looking for. Pero ang final answer niya is ano daw yung magiging product ng two numbers nito. So simply, you multiply negative 4 by 4 and that gives you the final answer, negative 16. Okay, very simple problem lang naman siya, no? Ayan. Another problem. Engineers are designing a box-shaped aquarium with square bottom and an open top. The aquarium must hold 500 cubic foot of water. What dimension should they use to create an acceptable aquarium with least amount of glass? Okay, we have a square bottom. It must hold, so it must have a volume of 500 cubic foot. Square bottom, open top. So let's try to draw that one. Right. Ayan na lang. Ba yan? Okay. So, parang ganito yung magiging itsura niya. O, bawal ang basher. Basta, naiintindihan niyo siya. Ayan, nag-sway na tuloy. Square bottom, open ang top niya. Okay? So, what we need to have here is the least amount of glass. Least amount of glass, that means least surface area. Tama? So, the surface area is the variable that we need to minimize here. Okay? So, getting the surface area of this one, establishing that relationship, lagay natin na x ang kanyang dimension sa bottom. And since this is a square bottom, x times x, and we have a height here, which we do not know yet, which is y. Ayan. So, if we want to get the surface area, take note again, it's an open top aquarium. So, surface area at the bottom is x squared. And surface area at the sides would be x times y. And we have 4 sides for this box aquarium here. So that will give us 4xy. Alright? Then, next is step 2. We need to identify another equation that will parang relate the other two variables. And that is using our volume. Tama? Kasi sa volume dito, ayan, from that volume there, we have 500. Volume is area of the base times height. Okay, I'm sorry. Area of our base here is x squared. Height is y. So that expresses our volume x squared times y. And so y, we can express y as 500 over x squared. So given that y is 500 over x squared, we can input that value here. So that our surface area now would become x squared plus 4x times y, which is equal to 500 over x squared. Simplifying it a little further, we have x squared plus 4 times 500 is 2,000. X over x squared would be x. Okay, so I'll write it this way. 2,000 x raised to negative 1. Now, we can differentiate it for step 3. So, we need to get the derivative of the surface area with respect to x. So, this would be 2x. This would be negative 2,000 x raised to negative 2. And that should be equal to 0. So this would be 2x is equal to, moving this onto the other side of our equation, that would be positive 2,000 now. And we have x squared on the denominator side. Then cross multiplying this would be 2x cubed, right? That's 2x cubed is equal to 2,000. Dividing 2 on both sides would give us x cubed is equal to 1,000. Taking the cube root on both sides, cube root here, cube root there, this would be x, and x would be 10 feet. So, ang bottom of this box would be 10 feet by 10 feet. And y, how much is y then? From this one, 500 over x squared. So, that should be 10 squared. That is 500 over 100. Therefore, y is 5 feet. So, dimension natin would be 10 feet by 10 feet. That's for the bottom. By height, 5 feet. And this dimension daw would give us the least amount of glass, the least surface area. All right.